read, and it blew my mind because, and it's what I wanted to make sure you knew, and some of the things that I tie in with it. So I wanted to see you and let somebody know, in case you didn't, but I suspect you do. For example, I remember that there was north of Cape Town, there's the West African desert. And in the desert, people would go in there and dig, and they'd find diamonds and gold and other synchrons and other kinds of jewelry in there, and they were digging it up. But the guy that ran Cape Town would send out police basically on horseback, etc., and see anybody to shoot him, because they didn't want him up there. It was his diamonds and his emeralds and all the rest of the stuff that was there. What they had classified it was that Mother Nature actually made a machine that was an atom smasher, and it actually worked, and they ran, and that's how it got all that activity to make all those stones and things like that to show that was the idea anyhow. I don't think it was at all. I think what it is it's this new technique that you discovered that we're using two elements on the lanthanum periodic chart. They sit way over there. At the moment, I can't remember the name of either one. I've got dementia up here, and I've got a middle block, but there's two of them just concatenated next to each other. And the sun uses those, the atomic structure, to sit down there and keep adding protons so that I laugh because everybody's making fun of the electric car. Who's making the electric? Tesla? Tesla's making the electric car. They said that there isn't enough lithium in the world for all the batteries he's going to make for all his cars. And I'm laughing because right there in that little article, they're already telling you how you make lithium, starting out from just a simple hydrogen atom, and you keep adding protons onto it, and you get to lithium. And you use these things in that first row below the periodic chart. The two elements are just concatenated next to each one. At the moment, I can't remember the name of either one of them, but they're sitting out there. And they essentially act as a piece of thing that will stick to the next proton onto the deuterium, and even though it kicks off, it gets pulled back on, all right, in a tricky little way. And it seems to work from the experiments I've already run, all right? And I think that's actually what happens and what you would classify as a hot spot in the Sahara Desert took place. And it's your scheme is actually how Mother Nature made that a reactor and got all the other stuff in there, because it finally worked up into the uranium sequence, and you had a real fire, like an atomic bomb going off in there, and you sat down and produced all that jewelry and emeralds and all the rest of the stuff in that pit. And it might be worthwhile for somebody to arrange a trip out there to find that thing, to see if indeed it is your scheme and not some magic of Mother Nature doing one of these machines that we built to try to compress all that stuff inside of it, none of which worked. Got okay? So that's one point to make. And the other one is, I've already hinted at that it's real easy, you know, the lithium, there's a whole mountain, top of the mountain anyhow, in Chile. It's nothing but lithium sitting up there on the ground. Right. So that's one of our sources of lithium. The other source is Mongolia, interestingly enough, and that's a big source of lithium. But otherwise, around the world, there's not another source, real source of lithium that they know about. At least I know about as well. But here, with this process that was talked about in that article, you were making lithium and there's not going to be a problem. So somebody ought to invest in into that all electric car.
Yeah, the problem is that we understand the formation of the elements like lithium, helium 3, helium 4, lithium 7, using what you said. We call this Big Bang nucleosynthesis. Big Bang nucleosynthesis is the mechanism.
Big
Big
Bang.
Bang nucleosynthesis, no?
Yeah.
And what happens is what you said. You can have reaction between protons, and if you have two protons, you can make H2. You put one more, you have helium 3,
Yeah.
helium 4, and you can go all the way to lithium.
Well, I'm sure they went. I'm sure
well.
in the Sahara Desert, they're using your process, and it probably got up there uranium, plutonium, and they probably did have a big reactor. But that's not how it worked. It's like, and I think also one ought to take another look at the big red spot on Jupiter, because I think your process is involved in that as well. I don't, there's a big question is, how did that arise, and why does it change in structure and stuff like that, and I think it's all what the people discussed, because they finally wanted to ask the question, how does the sun do it? Not how is man going to model the sun with machines and stuff like that to get the electricity out and all the rest of it.
And the problem is that the sun has enough energy to produce all the elements until iron. Because you have so much energy, you can build all the elements.
We keep failing at iron, I guess is what you're saying. Yeah.
Right. You can build all the elements inside the sun. You have so much energy. You have so many protons, and then the mass is so big. The gravitational force keep them together, and then you form all these elements. The only information we have from the sun is that we get neutrinos from the sun.
Yeah.
And the different nuclear reactions that form all the elements. In this reaction, you can get neutrinos from there. And then we measure, a professor from University of Princeton, John Bacall, he was able to measure every flux of neutrinos from every nuclear reaction inside the sun. And that works pretty well, but only all the way to iron. But still, we cannot make uranium. We cannot make in the sun. You cannot make so many heavy elements. But at least that part works well.
Well, somehow the sun is making these two elements that are sitting down there almost totally to the right of the lanthanum series on the bottom. I wish I could remember the names of them offhand, but that's part of my dementia, and I just can't dredge them up. I would say selenium, but I'm not real sure about that name.
Yeah, could be.
And the one next to it. The two are actually adjacent, that are involved in the stuff that I read in that IEEE magazine. So that's why I wanted to see somebody down here to let them know my thoughts about that, because somebody might make a trip out there to Africa to find out exactly what that was. And if it is, that's a hot spot on Earth, as like a hot spot on Jupiter, like a hot spot on some of these planets we're seeing.
Yeah, we can find the people, we have sometimes, we found in Russia, Ukraine, or many places, there is a lot of uranium, right? Uranium 235, uranium 239, all these heavy elements.
Heavy elements in there, you wonder how they got there.
Yeah, we don't really understand it.
I understand, but the process, just trying to understand how the sun did it. I think you found the basic process.
Oh yes, that's actually true. The point is that the sun never makes uranium 235 go all the way to iron 63. It's very hard to put so many protons. Uranium 235 means 235 protons together. And then how do you make that stable?
And here Mother Nature is using them on the actinium series. Those are already big atoms, heavy, and they're in the process of sticking the stuff onto each other. So it's I don't know the quantum mechanics at all to figure out how it's actually doing electronically. I see from the experiments that they did, and reported on, that I can see what they did do, and it must be that it works real nice and smooth.
You see, you need to you can get 2 protons and you can make H2.
Yep, no problem.
Then you can get one more and do the helium-3.
Yeah, you stick one
and
on there.
you all the way to lithium-7 and you go all the way to iron. But it's very hard to put so many protons to get something like 235 or 239. It's actually very, very, very hard.
So they go on to the lactin that you're searing, and then
sun does this.
they use that electronic structure of it to make it sticky, and they're able to. Apparently, it's a little tough to put in there, and they talk about it being stuck on there as if it would come off real easily, but when they do it, the new scheme that we're talking about, they mention that it's very sticky, and that's all it needs to do.
Could the sun have lost power?
Yeah.
I mean, it seems to me that maybe when it was newer, it had more oomph to do things like uranium-235, 239, but now it's lost enough power to create those heavier elements, and now it can only get as far as iron.
Could be. The problem is that we don't know. We know only how the sun works in the last, let's say, 300 years or something like that. And then so far it's losing energy every day, basically emitting neutrinos to us, because the neutrinos, they don't have electric charge, and they can escape very easy. The photons, we get a lot of photons every day. However, we get photons only from the surface around the sun, and they inside they are not able to escape because they scatter and they stay
too fast.
And they stay inside, and they can build many elements. Then in the center of the sun, we believe there is a lot of iron, and everything is very hot around. But we don't have, at least experimental information, that the sun had energy to go all the way to build something like uranium 235. Because we need a channel. We know how we know this reaction, because in some of these reactions we get a photon, we get a neutrino, then we put a detector here in our planet, and then we can watch what is happening. And this is actually one of the things that John Bacall did from Princeton University, that he was able to measure all the flux of neutrino every day that we get. And we actually had here a Nobel Prize winner in this department, Frederick Reines.
Yes.
You maybe remember.
I knew him.
Oh, you knew him?
Yeah.
That he actually was the person who discovered the neutrinos, and then he had many of these experiments. Yeah. He left to California to UC Irvine. But this is.
I think when he disappeared from Case, he ended up. God, and I just went right out of my mind.
He became the dean at UC Irvine, California.
I think he got stuck there in the Carolinas on the big reactor that they had stuck. That was one of the things that he was using.
Yes, you're right. Yeah.
So that, and then he didn't seem to be sticky here.
Well, he became very famous.
He was here for quite some time.
Yeah, he was here in the 60s. Yeah.
But that's my, I'm more of the computer scientist, etc. We started with my claim to fame up there at Wisconsin was the fact that.
I love Wisconsin. Yeah, this is the place that.
Were you up there on those machines, the 924?
No, because I am a little bit younger. I was only in 2007 to 2012. 2007 to 2012.
Wow.
No long ago, but I really love that place. My career changed completely there.
Yeah. So they had this big AEC contract, and they bought a lot of equipment. Instead of having one drum memory, would have two of those big, huge drum memories sitting in there. And then they had disk packs galore, tape units galore, all from Control Data out of Minneapolis, St. Paul. That company, most of the stuff was that. And that was in the computing center, and down, let's see, I think it was on something like the 4th or 5th floor, and the 3rd floor was where the physics was, and they had a 924 in there. And when they were working on the 924, they found out that they seemed to have something they attribute to static electricity. And so they got a 4-inch square cross section iron, copper bar, and they ran it diagonally in the plenum air, because the machine sat on top of a false floor. The air was a plenum air to cool the machine. And it ran diagonally clear across the room, and everything you see, there'd be a pad in front of a control console, and the pad would have a wire that went down through the floor and attached to the copper bar, so that everything was grounded on one point, all right? Even the printer had a little static pad in front of it, and you could see the little wire going underground to that bar. And for the 110 plug into the wall, they had a big iron donut that was about this big around, with the center about that big, and you had to put the 110 cable in there, wire it up a certain way in order that no static electricity would come through that way into the machines and form it. And they had it all protected like that. And the problem is, they knew that there was some problem somewhere with static electricity, because they were still trying to eliminate all of it. This is where they wrote everything in the 924 and take the tapes and go up to the 3600. The first thing they told me, hey George, all the stuff sits there that will attach the 924 to the 3600, so the two of them can talk to each other. Will you write the program to do that? And I said, okay. So I wasn't doing anything else, and I sat down and designed the whole thing, and it worked like a charm. And the next thing he said, well, George, we want you to write a program to check it out, do an acceptance test. I says, we're not supposed to ask the guy that designed the program to check out his own program, because obviously the answer is going to be everything is working just fine. But I played it honest, and I sat down there, and when I did it, I sat down there so I could generate all the records I was going to pass up from the 924 to the 3600, and the way it was is, it'd start out if it started out at 924, it would write it up to the 3600. 3600 would turn around and write the same stuff back down to 924. When it got down to 924, you could compare it to the record that we've read up. It was different. There's a problem, and they were different. And the question was, why were they different? Well, they finally, I think physics wanted to find that out more than I did, and they came back and told me that it looks what's happening is the remainder register on the 924 is taking an extra right shift. And I said, really? And he said, yeah, because I generated the scheme, and they just see that it was shifted by one. And I said, anybody look at the back panel? And they said, yeah, it's kind of strange that there's 2 wires coming on down the lug that seems to be for that register. I said, we're going to have to call Minneapolis, St. Paul, and get one of the designers down here to take a look at the back wire. He came down there and took a look at it and said, this wire doesn't belong. When he pulled it, guess what? All their static electricity problems disappeared, and I had a reputation as having found it with my test program.
Yeah, after Wisconsin, where did you go after Wisconsin?
I went down to Florida, Harris Corporation, and where was it? It's
Palm Bay?
Palm Bay is where
Melbourne?
I lived, and it's on the coast. It's been bad recently.
Is It's in Tampa or close to Tampa.
No, you're on the wrong side. You're on the Caribbean side.
More like Hollywood.
But it's on the ocean side. and
Melbourne.
It's about halfway.
Hollywood.
Melbourne, Florida.
Melbourne.
Yeah.
Yeah, Melbourne, Florida, where it was, and I was there. I got a reputation because there as well, because I knew what problems I could diagnose the problems. One time, a good friend of mine came in and said, "George, I'm writing this program for it was Datacraft. They bought it from Fort Lauderdale. That was what it was called, the Datacraft. Everybody up there at Melbourne called it the Datacrapper because the point was it had the speeds to compete with the deck computers that were being made in that range, and they wanted to compete in that area, so they jiggled stuff around. But one of the things that they did was they made the instructions 2 words instead of 1 word to get all of the variations for the deck machine that was going to be their competitor. It had the same speed as that machine already, but didn't have all the features in it. So they put all the features in.
What kind of calculation you guys made with this computer?
What kind of
calculations, or what kind of things you?
Anything, everything, and sometimes it was all dark stuff that, with respect to communications, because that was one the encryption of all the communication lines and stuff like that. That little schema where you broadcast at the right angle inside of a big sphere, and it tells you what kind of communication you're dealing with. That's how they could find out where. Remember, it was I think it was one of these. Hollywood actors, very smart. She invented this little scheme that frequency hop all over the place. Well, basically you had a big sphere set in there, and it would hop around in there for changing the frequencies involved in the encoding and stuff like that.
Rita Hayworth?
Rita Hayworth? No, not Rita.
Not Rita.
There were 2 sisters.
Yeah, I'll
both
think
of
of
them are very smart, and one of them would be on the stage and doing rock.
Yeah, we call this today a cavity. I actually am teaching now.
Oh, you're teaching that.
Classical
So that's what it was, and let's see. I started down here because we were telling me, about that. But what they did was they doubled the instruction length, which means they had 2 words for instruction now on this machine. So my friend came in and said, "George, I wrote this program and it almost worked, and I realized that there's instruction up front at the beginning of something like 1,000 lines of code." And said that I found out that I had to make a change there to correct the problem. And when I did, all of a sudden I got a memory error. And he said, if I take the instruction out, I don't get the memory error, and I seem to be able to move that instruction around, but it's not where I want it. All right. And I said, well, I know exactly what your problem is. The Datacrapper takes 2 words per instruction, and you stuck a instruction up at the beginning of your program. Where did the rest of your program go? It's sitting down there, and you keep looking, and the problem is you got the 1 word that is in the same memory bank, but the second half of that instruction is in a different memory bank. He says, "You're kidding me." I says, "No, I'm not kidding you." And he finally figured the workaround for that. But that was what kind of thing I could do and expect. And when somebody come up with a problem, I usually had a good idea. But I started in composition. They were the ones that produced the Wall Street Journal form. In fact, the friend that I was just talking about, he actually did the stock listing in those papers. What was the big paper at that time? But it lists all the stocks and what they were selling for, things like that. That was all formatted on the disk, and all kinds of you know, you got disc after disc whirling around inside this thing that did that setting of the stock quotes on the back of the big economic paper that would come
Wall
out.
Street Journal?
Well, yeah, sounds like the Wall Street
Yeah.
Journal. You know.
What was the
I've
other-
kind of forgotten what the names of them were.
Only
So-
York Times.
Yeah, he had that stuff there, and that was my friend, and he wrote another program for the system when all of a sudden this broke out, because we were trying to at the time there was a new programming language, Ada, and I was strongly involved in that, and that was the programming language we wanted to use, and for the new system, because it tended to conserve things rather than leave things hanging around. And
You never use Fortran? You never use Fortran?
oh yes,
You use it, okay.
oh yeah, I know Fortran.
He
There
can
is-
read binary code.
You might even be
Yeah.
able to find here somewhere a P6. That's Petsnick's pig package for poor programmers, about something like that. You know, we were on an IBM 650, and people from outside would come in and run their little programs out there and try to debug it. And so I'm there with Fred Way. I don't know if you ever met Fred Way, but he was the assistant director, rather sharp. The director changed so many times that I can't remember all the name. One of them was a piano player of what kind of music? Kind of rock, not rock and roll, but
Jazz?
there was a type of music that they played in, and I can't remember the name of it anymore, but that was his specialty. And he wrote a book on Turing computability or something like that. And they made him head of the computing center when I was there. We had an 11, one of the first UNIVACs, and there was a big window in the door that you opened because you could walk inside.
Yeah, right.
And got inside, and there were the 4 memory tanks for the memory. But you had to be careful because you were looking at all the lugs that are sitting there bare, and you get up about it, you get electrocuted because they were those big tubes.
Right.
All right.
Right.
Yeah.
Something like 500 volts of currents or something like that they were using.
Yeah,
Well, I had fun there. One of the suggestions that the assistant the one that liked to have fun, wanted to do is he wanted to take the big glass oval on that door into the memory inside the machine, and he wanted to make a double plane and seal it, be watertight, and he was going to put water in there and goldfish.
What was
Well, he was somewhat of a joker. That was his
Yeah.
idea of decorating that.
what was
And,
your other observation? Didn't you have another thing you wanted to share? I thought you had two observations you wanted to share.
God, I can't remember.
Besides the working of the sun
Uh,
for physics.
well, I think the business with the Africa. All right, that somebody. It would be interesting, perhaps, to go out there and find out, was that really an explosion that took place in this big hole that produced all that stuff, or was it a hot spot, a la your technique? I think of it as the hot spot these days. The hot spot that's there, like the hot spot in Jupiter, like the hot spot that they see on some of the worlds that we can see now with the Keck telescope and things like that. That's how the sun is actually doing it, and you can forget about all the other machines. In fact, the whole idea of that article was the fact that you can forget all about those machines. This is the way it's going to be done in the future.
What happens?
I don't know how far you got. It went to the think box business. I don't know if you were the professor that gave them the two engineers that were involved in it. In the pictures, I could see there were two of them that worked together, and they successfully found out how it did by beginning with the idea that how does the sun do it, not how does man ape the sun and fail again and again and again and again and again.
What happened for heavy elements? The best theory that we have is that when there is explosion of stars, often we get things in our planet, and for many thousands of years, we got like collisions in our planet, and these collisions actually brought new type of material
New material.
coming from the explosion
From them,
of stars.
off of them, and probably be used
Right.
in the process of.
And that is
doing it
the best theory that
that
we
way.
have is from the explosion of a star we have heavy elements.
Yeah.
But so far from the sun, no. But the point is that when we have a collision in the planet and we find heavy elements, we don't have enough information to say where this came from.
Yeah, that's
That is very
yeah,
hard, you know.
because you don't know whether it came from outer space
Right,
or
right.
somehow it boiled up out of
Right.
the magna that's usually the center of all these large planets.
Right in the galaxy.
So,
Right.
yeah, whether it's a volcano, it gets up there and we get a volcano at the top, and that spreads all this stuff at the higher levels, etc.
If
But
you
your process doesn't involve that, really.
No, it's not
Yeah,
possible.
it's really, really unique, and I think it's therefore all the more important.
if you drill through the earth from Chile, will you get to Mongolia? Are they opposite in the planet? In my head, they are.
They could be one can check
Chile would be the North Pole. Chile's almost the South Pole.
It's a South Pole.
But Mongolia is pretty north, and
right, but
China.
But I think Chile is closest to the South Pole, and then
Yeah.
you will have to go to north, maybe
Siberia.
Siberia.
Yeah.
Certainly above Canada.
Yeah, above Canada.
It just would have been
And Northwest
elegant
Passage.
if somehow the lithium that's on the planet is.
Well, you know, we
Well,
have
nobody
experiments.
knows how the lithium got up there. in
Well,
Chile.
If it was something that.
You know, we have actually experiments today. You take the planet, right? And what happens is that you can put, you can ask the question, how do you know what is inside the planet, right? But we are lucky to have neutrinos
Yes.
that you can put a nuclear reactor here. There are many experiments. You shoot neutrinos here, they travel, and then you detect
They're going to come out the
right?
bottom, yeah.
And how they behave, how they change,
Change on the way.
we start predicting the collisions that they have and what kind of materials you can have inside. And then you can do the same here. And this is called neutrino tomography. Tomography. Then this is done.
I haven't read anything on that.
There is a new experiment, Fermila Chicago, a Fermila,
Yeah.
that they send now neutrino from Chicago all the way to a submine in Minnesota. But this is just to understand better
That's
the
not a long
neutrinos.
distance.
This is not a long.
Yeah.
But then people can do. You have. There is a proposal. You can send neutrino from Chicago and to Korea
Aha.
and
Yeah.
Japan.
You're
They
really
are the
going
two.
through the mantle.
Especially the Japanese, they have a good. They have a detector. It's called the Super Kamiokande.
Yeah, I've seen pictures of that.
Will be called now Hyper Kamiokande because it will be larger.
Yep.
And this is the only thing we can do. We can actually map inside the
So
planet
you
what
can-
is
you can get an idea what's in
the
there.
idea. And then you will make different models and
Yeah.
try to understand the neutrinos scattering.
It's also impressive that
It's the only thing.
of all the planets that we know in our system, solar
Right.
system, that the Earth is the only one with plate tectonics. So the surface of the Earth is always changing.
But something that is even more exciting is the only one in the solar
It means
system.
that when we get buried in the ground in a coffin, all right, that coffin is going to actually get into the mantle and burn up.
Someday, maybe.
So all of us are going to hell, all right?
It's the only one that has a magnetic field. For example, suppose that you come from a different galaxy and you see our galaxy,
Mm-hmm.
There are two planets. They are very close to the sun. If they will be protected, we will have the same temperature. We will have the same atmosphere. This is our planet and Mars.
Mars.
But what happened with Mars is Mars lost the magnetic field.
Oh, it doesn't have a magnetic field
It doesn't
anymore.
have a magnetic field. Then we have a magnetic field that protect us from the sun, means all the radiation, the magnetic field clean a little bit. And we have an atmosphere, means that water doesn't boil and doesn't disappear. That's why we can have life in this planet. And actually, next class I am showing the students how to make a model to make the magnetic field of Mars.
The only thing I've read about Mars is the fact that they're full of earthquakes up in Mars.
Right,
and
right.
You're not too sure why there's many earthquakes.
Because
Mars
you
isn't
could have
that big.
internal activity, but the point is that you only can have an atmosphere
Sure.
if you have enough the right temperature and pressure. But if the sun is bombarding you and heating you all the time, the water disappears. Therefore, you never can have anything that live in water there.
Yeah.
This is the normal life that we know. Maybe there is a different type of life that
Yeah, they
doesn't
got
require water, but we don't know about that.
They got those big canyons on Mars as well, and they're finding earthquakes like crazy on Mars. So.
Yeah, there are crazy people that they want to explode nuclear bombs in Mars to see if they can activate the nuclear
Oh,
magnetic
no.
field. Yeah.
What time is it running? We have to go.